Combining functions. Given f of x equals x minus 6 and g of x equals 3x squared, first find f plus g, f minus g, f times g, and f divided by g. Then determine the domain for each function. First, we're going to find f plus g. That just means that we're going to add f of x plus g of x together. So f of x is x minus 6, and we're adding g of x, which is 3x squared. We can't combine any like terms, so our answer is just 3x squared plus x minus 6. These two expressions are the same. I just wrote the final answer in descending order according to the exponents. Now I want to list the domain of this function. Since we don't have any rational expressions or square roots, then the domain of the expression is just all real numbers, or negative infinity to positive infinity. Now we're going to find f minus g. And this is f of x minus g of x. So I'll write f of x, which is x minus 6, and I'm subtracting g of x, which is 3x squared. Again, I can't combine any like terms, so I'm going to write my final answer in descending order according to the exponents. So I have negative 3x squared plus x minus 6. And again, the domain is negative infinity to positive infinity. Now I'm going to find f times g. That's the same as f of x times g of x. F of x is x minus 6, and g of x is 3x squared. So I'll distribute the 3x squared to each term in parentheses. So I get 3x cubed minus 18x squared. I can't combine any like terms, so this is my final answer. And again, I don't have any fractions or square roots, so I know the domain is negative infinity to positive infinity, or all real numbers. Lastly, I'll find f divided by g, or f of x divided by g of x. This equals x minus 6 divided by 3x squared. Now I can't cancel any like factors, so this is my final answer. It's already in simplest form. This answer is a rational expression. That means that there's a variable in my denominator position. So the domain is all real numbers except for those values that make the denominator 0. To find those values, we're going to take the denominator and set it equal to 0 and solve for x. So I have x squared equals 0 divided by 3, which is just 0. And if I take the square root of both sides, I get x equals 0. So this tells me the value that x cannot be because the denominator will go to 0. So that means that my domain is all real numbers except 0. And I'll write this in interval notation as negative infinity to 0, union 0 to positive infinity. So that just includes all real numbers, but it took out the value of 0. For f of x equals x plus 1 and g of x equals 5x plus 5, find the following functions. A asks asks us to find a composite function, the composite of f and g of x. This means that we're going to take the function f, and wherever we see an x, we're going to plug in the expression for g of x. So the function f of x is x plus 1. So instead of an x, we're going to write a g of x. So this is g of x plus 1. And then I'll substitute the expression for g of x, which is 5x plus 5, and then plus 1. And then we'll simplify this by combining the 5 and the 1. So my answer is 5x plus 6. Next, we're going to find the composite function of g and f. So we're doing the opposite. We're going to take the function g, and wherever we see an x, we're going to replace that with f of x. So g is 5x plus 5. So we'll have 5 times f of x plus 5. And f of x is x plus 1. So this is 5 times x plus 1 plus 5. We'll distribute the 5, so we get 5x plus 5 plus 5, and then combine like terms by adding the 5's together, and we get 5x plus 10. Now we want to know the composite of f and g of 2. So this means that we're going to find that function, which is 5x plus 6, and we're going to plug in a 2 for x. So we'll take the 5x plus 6 and substitute a 2 for x. So this is 10 plus 6, which is 16. So our answer for C is 16. Next, we want to find the composite g of f of 2. So I found that expression in part B. So I'll take that expression, and I'm going to plug in a 2 wherever I see an x. So this is 5x plus 10, which is 5 times 2 plus 10, which is 10 plus 10, and that gives me 20. So my answer for part D is 20.